Welcome back. Today we will cover one of the most important concepts, which is density. The importance of density is undeniable, and it plays a huge role in our life, and we will discuss it. For example, density denotes the greater quality of several petrochemical products, such as gasoline, kerosene, and many more. This in turn enables us to classify and label these products, which also determines the price of those petrochemicals product itself. So what is density? Density is a measure of the amount of matter or mass that can fit in a given space or volume. By definition, density is the mass of matter divided by the volume. The sign is rho and its unit is kilogram per cubic meter in International System of Units, SI. There are also other units of density, like pound per cubic feet, kilogram per cubic centimeter, and etc. Density can also be understood by looking at how tightly a matter is compressed together. Basically, the more items that can be fitted into fixed space, like a container or bunks for the space, that becomes denser with each addition. To have a clear idea of density, real-life examples would be just perfect. Let's imagine an elevator with just one person inside it. As the elevator moves in each, for a new person gets in each time, the elevator becomes denser than before. So, the next question is, why do we need density? To give an example for process engineers in the field of fluid mechanics, density has a huge sense because it affects whether the fluid will sink or float over another fluid. And this in turn is going to affect the methods and technology for separating these two fluids from each other. Density is also used to differentiate light and heavy types of oil. Light crude oils tend to have lower density values compared to crude oil, which is rich in heavy K components. Therefore, the density of the crude oil directly affects both its quality and its price. Here you can see some fundamental density values of STP. And density is a very fundamental physical property. It is used in most of the chemical engineering calculations to design different equipment and systems. And in the next lesson, you will learn how to apply density calculations with real examples. So see you there. Welcome back. Once you have completed the chapter about density, we can switch to the exercise. In this exercise, you will be given 3 problems to solve. The purpose of the first 2 problems is to be able to calculate both liquid and gas density separately, while in the last exercise, you will practically analyze the relationship between temperature and density. As you see, we have already created a template for you to ease your workload. Moreover, we provided you with the required data that you don't spend your time on. Let me give you the individual instructions for each problem. In the first problem, you will calculate density value of the given liquid mixture and then find the error value between value from Aspen and value calculated by using the percentage error equation provided in the worksheet. The same procedure will be followed in the second problem, where you will calculate the gas density. However, in the calculation of the gas density, you will need to find the molecular weight value of the gas mixture and then use your calculated molecular weight value for the calculation of the gas density with the help of the equation provided in the worksheet. And finally, in the last problem, you will collect all the density figures for the given components, then draw the table, which represents the difference between density values at 2 different temperatures. More exactly, 38.1 and 20 Celsius. Yep, that's it. I hope you all will solve this exercise successfully. Good luck!